Oh, good tune to start the notes today. Under pressure. Da 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 ba ba da da ba. All right. Why are we talking about pressure? Because we have to talk about gas laws and how do gases get affected. There are three ways in which we can study a gas and how a gas interacts with things. So, what are those three ways? The three ways in which we can study gases are volume, temperature, and pressure. And we also can talk about the number of particles, but we're not really going to focus on that one this year. So the three ways in which we can study a gas: volume, temperature, pressure. All right, VTP. So those are the three ways in which we can study a gas. Pressure. Oh, we got some cool stuff going on with pressure. And we'll talk about pressure too later in the year when we talk about physical science. But here's a couple things about pressure. What is pressure? It's the force you create over an area. So if you are standing on 2 feet right now, you have pressure on the soles of your feet. The entire weight of your body is your force, and the area is the amount of the area of your feet making contact with the ground. So do you have more pressure on 2 feet or 1? Think about it. Do you have more pressure on standing on 2 feet or 1? You have more pressure standing on 1 foot because you have less area on 1 foot than you do on 2. So we'll talk a little bit about pressure as we go. The units are newtons per square meter, and usually what we call the units for pressure is we call it a Pascal. And why a Pascal? Because he's the guy who kind of worked with pressure. So if you discover something really cool in chemistry, guess what? You get to have your name after it. So one day when I discover something, either a unit's going to be Clenert or I'm going to find an element and it's going to be called Clenertarium. So get ready for that. So 1 Pascal is a unit of pressure. It's a really, really small unit of pressure. What is the unit of pressure that we use in the United States? Anyone know? Think about when you're inflating car tires. What do you inflate your car tires to? What's the unit that you want to use for that? PSI, or pounds per square inch. That's the American kind of English unit that we use for pressure. In science, we're going to talk about pascals. And last year in 8th grade, you might have learned a couple different units of pressure, but we're going to focus mostly on pascals for pressure. So, gas laws. 3 ways in which we can study a gas: through pressure, temperature, and volume. We talked about pressure. Let's talk a little bit more about it. A large amount of gas particles will collide at the same time, will produce a large amount of pressure. So what this essentially means is if you have a lot of particles colliding, it's going to create more pressure. So the more particles collide, it's going to create pressure. If you have that happen in a closed container, you'll really be able to notice the pressure. If it happens in a large container, such as like the Earth, you're not going to notice that pressure buildup. So something important there. You have pressure pushing down on you right now all the time. In fact, the weight of the air pushing down on you, this is kind of a cool stat, 14.6 pounds per square inch. Which means this: if you got a tattoo on your body in a square inch, so think about an inch by an inch. If you got a tattoo of a square inch on your hand, that would be 14.6 pounds pressing down on that part of your hand. You don't even notice it, though, because we're so used to it. Your body's accustomed to it, and your body pushes back at that same force. So that is a cool thing about pressure. Right? Speed and mass will also affect pressure. Just a couple things that will affect pressure. All right, so there's a little bit about pressure. We'll go more into pressure. I'll do some pressure demos tomorrow. I'll have some pressure kind of ideas, but we'll also talk about it later in the year when we talk about physical science, even though we're focused in chemistry right now. Temperature. If you increase the temperature of a gas, you will increase the pressure. So one way to remember that really is increase the P, increase the T. Why, if you increase the temperature, are you increasing the pressure? Well, it's pretty simple. If you increase the temperature, it gets hotter. Particles move faster when they're hotter. If particles move faster, they're going to collide more. Collisions create pressure. So if they're moving faster, they're going to have more collisions. It's going to create more pressure. So that is temperature. Right. Volume. If we decrease the volume, we'll increase the pressure. So here's kind of decrease the volume, increase the temperature. How do we do that? Well, let's say I have all the gas particles in this room and I want to compress them down. How many of you, or some of you may be familiar with how like engines work and a piston works in an engine, right? What's a piston do? A piston pushes down in a cylinder and it compresses gas. And then it comes up and then it pushes back down again and it compresses gas. When the piston pushes down in an engine, it creates heat and friction. That's why we need motor oil in our engines. All right? So that's why engines create heat. That piston is compressing that air, making it smaller. So it's decreasing the volume, increasing the temperature. Right? And the number of particles, if we increase the number of particles, we'll increase the number of collisions and we'll increase the pressure. So there's a little bit about pressure. So we'll continue to talk about pressure. I'll do a couple demos with pressure tomorrow, and then we'll move on from there.